Hi students, this is lesson 1.5. Go ahead and take notes on this and obviously pause at any time so that you can work through. So our learning goals today are that you can write a piecewise function from a situation in a graph. We're going to focus on the situation today. You can solve and interpret a piecewise function in a given context. So this is really going to get at why we would need a piecewise function. Your criteria for success for these scenarios is you're going to first identify the variables. You're going to translate the situation to an equation. You're going to also translate the situation to the restricted domains. You will choose the correct function and substitute appropriately to solve. And then when you interpret, you will use a complete sentence. Okay, so here's the example. It's just going to be one that I'm going to go through with you. So I would definitely encourage you to annotate as you are looking through different problems. We are going to work on a scenario sheet that is in your packet. So you'll be able to write right on there. Or even if you're using the PDF or you're just looking at these on the video, you can always just write down, jot notes for the important parts of this problem. I would always recommend you reading the problem 2 to 3 times before you start digging in to make sure that you understand the situation. Okay, you are going on an adventure to explore San Francisco for the day, and you've decided it would be easiest to get to the city by using Uber. They are always driving around and can drop you off right where you need to be. An added bonus is you don't even have to deal with the headache of finding a parking spot. So right here, let's see, and that convenience comes at a cost. I'm already saying, like, this is the background. The gist of this is we're taking an Uber. An Uber from Fremont High School to San Francisco charges the following. Okay, so we're going from Fremont to San Francisco. There is a $5.80 flat fee for the first 2 miles. And this is fictitious, so I don't know what the actual information is. So this is our unique Uber. We have $1.20 per mile for each additional mile. So note that you've already traveled 2 miles. Once you go over 2 miles, you get this new fee. And then it says once you travel over 30 miles, the rate changes to $2 per mile. So you're looking at this to see how we can represent this using some variables, and then we're going to actually write our own piecewise function. So let's go ahead here and let's identify our variables. So I'm going to say let x equal number of miles traveled. And we're also going to say let f of x equal the total cost of the trip. Those are the 2 things we don't know. We're taking this trip. We haven't said how long the trip is mile-wise, and until we know how many miles, we really don't know the total cost of the trip. So those are the 2 quantities that are unknown. Now, if that does not shout out at you, again, you're going to read the problem a few times and try to identify which quantities are those variables that are going to be changing. Okay, so the first thing is telling us to write a piecewise function that represents this situation. So I'm going to go ahead and call this piecewise function f of x. I'm going to draw in some curly braces here. And I need to think about the different restrictions and what the cost is going to be. So the first one says we have a flat fee of $5.80. $5.80 would be the flat fee. And when you think about this on a graph, we're going to think about this as the miles and this is the cost. Okay, so for this $5.50, this is going to give us a constant where we're going to just have that horizontal line from 0 to 2 miles. So we want that constant from 0 to 2. So we're going to say when the miles are less than or equal to 2 and greater than or equal to 0. Now, here's a little debate. I did put an equal to for both. However, if you drove 0 miles, you would assume you wouldn't pay. However, let's say the Uber was already there and you said, no, I'm not going to go in the Uber. I'm assuming you would still get charged for something because that person came out to pick you up. So that's my reasoning for why I put an equal to here. I assumed that the car got to me and then I said, no, forget it, and I'm still going to get that flat fee. The equal to on the 2 is because this original problem is saying, let's make sure here, it's saying for the first 2 miles. So that's why it includes the 2. Okay, now we need to think of the second piece. So the second piece is saying, hey, if you travel more than 2 miles, you're going to be charged $1.20 for each additional mile. So it's going to be $1.20 times each mile greater than what you've already traveled. Now let's say I did this. This is $1.20 times the miles traveled. That's not what I want because I already paid for those first 2 miles. I don't want to pay an additional $1.20 each of those miles. So you actually want the total miles, take away the 2 you've already paid for. Now, this gives you the extra portion, but we also want to make sure their total bill includes that $5.80. Okay, so it's if you traveled over, and let's get our restrictions here. If you traveled over 2 miles, but less than or equal to 30 miles, then you're paying what's on the left. So let's say I traveled 5 miles. If you go ahead, so let's just test this out. So if I traveled 5 miles, then I'd say, okay, well, that fits in this restricted domain, so I have to use the second piece. So I would say $1.20 times 5 minus 2 plus $5.80. Now let's see if this logically makes sense. It's $1.20 times 3 of the miles plus $5.80 for the initial 2 miles. And then that would be your total bill. So what I would say is if you're in doubt, put in an actual value and see if it passes the sanity test. Okay, now the third piece is talking about if you travel more than 30 miles. Now I also didn't cap this. You're not going to travel infinity miles, but I didn't restrict it because I wasn't sure exactly where the cap would be. And I think as long as you're paying, you can keep having this person drive you, like maybe you need to take breaks, but as long as you're paying for it, I would think you would be able to continue traveling. So we could cap this if there was a restriction on Uber and there was a certain, we only go X amount of miles away from this location. But in this case, I just left it for everything greater than 30 miles. It says for this, it's $2 a mile for every mile greater than 30. Take your total miles, subtract the 30 you already paid for. We don't want to double charge ourselves, okay? We already paid for those 30 miles. So it's $2 times the extra miles beyond 30. Now here is the tricky part. How much was my bill for 30 miles? How do we figure that out? We would use the second piece. So we would go ahead and say, okay, it's $1.20 times 30 minus 2 plus $5.80. And this would be equal to, sorry, I'm running out of space here. This would be f of 30. And f of 30 would be $39.40. So you want to say here is for beyond 30, that's the charge for each of those extra miles, and here's the part of the bill you've already had included for the first 30 miles. Okay, this is your piecewise function. These are the three restricted domains. These are the three pieces. You can see these pieces are all linear pieces, so nothing too crazy. But you can also see that we go from a constant function with the first piece, and then we go to the second piece that has a slope of 1.2, and then we go to the third piece with a slope of 2. So we are increasing as we go from left to right with the steepness, and therefore the cost is going to be more, which makes sense as we go on and travel further. Okay, letter B says, how much would it cost to go 42 miles? So we're saying this is the distance, and I want to go 42 miles. So you're going to actually write f of 42. So you're going to say, okay, Mrs. Wojcik, I'm using my function f, and my input is 42. Now you need to decide, where does 42 fit in the restricted domains? Well, it's definitely greater than 30. So it only fits in this third piece, and it will only fit in one of these pieces when you do this. Okay, so we'll say 2 times the quantity of 42 minus 30 plus $39.40. And you'll just go ahead and calculate that, and you would get for f of 42, for f of 42, you would get a total of $63.40. Now, you're going to make sure, I'm going to move up here, you're going to write this in a sentence. So you are going to say it would cost $63.40 to travel 42 miles. Okay. How far can you go with $25 in your wallet? $25. Okay, so let's think about where this would apply. Which piece would I use? And we're solving for x in this case. So it's going to be 25 equals one of these pieces, and then we'll solve for x to find out the miles. So $25 is more than $5.80. So I'm definitely going more than 2 miles. So that, to me, that rules out the first piece. The second piece, okay, we're looking at that. That's a possibility. Now let's look at the third piece. The third piece is over the 30 miles, and look at how much you would have had to spend, $39.40, to bump into this third category. So this tells me the category I want is the second one. So we're going to say 1.20 times x minus 2 in quantity there, plus 580. We'll subtract 580 from both sides. Divide both sides by 1.2, and we get 16 equals x minus 2, and x equals 18. Again, we're going to write a sentence to answer this question. The question was, how far can you go with $25 in your wallet? A ride that charges $25 is a distance of 18 miles. And you do not have to have it word for word, but you should always be talking about the input and the output. Input and output in those sentences. Okay, so here I have the cost, the miles. Here I have the cost and the miles. Make sure you have labels. Make sure you identify both input and output. Okay, in class, we're going to have time to look at a few other scenarios, and we're going to practice identifying variables, setting up the piecewise function, and then actually analyzing and answering questions using your function. Thanks so much for watching.